Okay, I wanted to show you guys, there were two balancing equations in particular that gave people some trouble on the worksheet. One of them is this one, the sodium, hydrogen, oxygen one. This one doesn't look like it would be bad.
That's easy.
It looks easy. Hold on one moment, Greg. 1 second. Greg, you can help me then. Hold on 1 second, okay? When we count it, this is what happens. So, Greg, do you know where to go from here?
Oh, I just kind of like that, like theory, like add them up and stuff.
Well, guess what? You might have done this and figured it out quickly just by trying a couple numbers, trial and error. But here's one trick. First of all, you guys have 2 hydrogens over here and 3 hydrogens over here.
I multiply it like that by 2 and that one by 3.
Sort of. You can't, Greg, because it's in 3 different places. So here's the trick. If you have 2 hydrogens on this side, and here you have 1 hydrogen, how can we get 1 hydrogen from H2? What times 2 equals 1?
2.
1/2.
1/2. Very good. Now you can't have a half of a molecule. But if we put this in here just for a second, okay, that's going to give everything, that's going to let everything be balanced. And then if you multiply this by 2, just like in algebra class, we're going to get 2Na plus 2H2O. What are the other coefficients here? Yeah.
2Na, OH, and then 1 H2.
And then just 1 H2. Okay, very good. So you can use a fraction to balance it because, again, everything else is perfectly balanced. And Greg, I'm glad you mentioned making the 2 and the 3 6. You can do that if the things are in 2 different, just in 2 places, but here they're in 3 places. So you can't do it that way.
How do you get 0.5?
Because 0.5 times 2 equals 1. So if you have 1 hydrogen and 1 hydrogen, that gives you 2 and it balances the other 2. And then you can multiply it by 2. Okay. Then the other trick for this one, if you have one with water in it, you can split it up like this. You can split it up into Na, H, and OH. Because water really, when water breaks apart, it breaks into hydrogen and hydroxide. Okay? It doesn't break into, it breaks into these 2 ions here. Okay, if you set it up like this, then whatever you put in front of the H2O, if you put a 5 here, for example, you're going to have 5 H's and 5 hydroxides. Okay? Right now, Justin, what is off balance? Which one's off balance, Justin? Hydrogen. So we need to do something here. Who knows where to put a 2? What are we going to be putting a 2 in front of? Not yet.
Well, no, it doesn't.
Okay, I'm glad you said that. You were saying almost over here. When you have, like, it's too much on this side. You don't want to put anything on this side. You need to put something on this side. It's like a seesaw almost.
We need a 2 on the opposite side of the 8.
Good, we need a 2 over here, okay? So when we put a 2 here, that's going to double these. Okay? And then what do we do next? Now where do we put a 2? I know this looks weird with the HOH in there. Where do we put a 2 now? Not sure? Good. We have to balance this now, so we put a 2 here. And then you will need your 2 here to balance that.
So that one's 1, right?
Yep. So again, guess
Yeah,
what?
see, I got that in like 2 seconds.
Good. Either way you balance this one, either
Yeah, I
by
still
making
don't
water
understand.
HOH or by using a decimal and doubling it, you get the same answer. Okay, hopefully everybody has that one because next I'm going to put up number 9, which was the hardest one on the sheet. Some of you did get this through trial and error. Okay. Number 9 is a carbon, hydrogen, oxygen one. And when we do one with carbon, hydrogen, and oxygen, you want to balance carbon and hydrogen first and oxygen last. Okay, so So let me get that up here, and we'll see if you guys, a few of you were able to figure this one out. C8H18 plus O2. Who remembers the products of a combustion reaction?
Oh.
If not, you need to know that pretty soon. Combustion reaction, complete combustion anyway, is CO2 plus H2O. So this was number 9 on your worksheet. Okay.
Did you
So,
already say the answer? I just remembered it.
so 1 second, we've got 8, 18, and 2. And now we've got 1, 2, and 3 over here. Okay, the trick to balancing these is you want to balance the carbon and hydrogen first. Why do we leave the oxygen till the end? Why do we not touch the oxygen until last?
Because the oxygen is, I don't know,
There's 2 reasons.
it's still not easy.
What's that? Oxygen is in 3 places here.
Wait, but 3 and 2 equals 7.
You're right, but when it's in 3 different places, you don't know what to put where, so you don't want to touch that yet. You want to balance the carbon and hydrogen first here. You don't want to put anything in front of here yet because you already have too much carbon and hydrogen. So, who can tell me what goes here and here? Abel. What would go in front of carbon, Abel?
1.
There is a 1 now. What should go in front of carbon?
I'm not sure.
Okay. Do you, who has it back there? Go ahead. What is it, Nate?
That's it, 8.
It's 8. Okay, good. We have 8 carbons over here. We need 8 carbons in front of CO2, right? That balances our carbons. We'll count the oxygen in a minute
That means
because,
there's like 16 oxygen.
well, there's
right?
16 oxygens here. But now what needs to go in front of H2O?
9.
Good. We have 18 hydrogens here. Some of you, when we looked at this in class, you said it'd be 6. You want 9 times 2 is 18, right? But now how many oxygens are there here?
9.
Okay, what is 16 plus 9?
25.
Okay. So now, what times 2 is 25?
14. No, wait, 12 and a half.
12 and a half. So you can either put 12 and a half here, or if your math is bad, you can even do 25 over a half over 2. So 12.5 or 25 over 2. And then same thing, we've got to multiply this by 2, just like algebra class. So we get 2 octanes. Plus how many oxygens?
2.5.
What the heck?
Wait, what?
12.5 times 2
Wait, why would you
is
multiply?
25, because you can't have half of a molecule.
So, alright, okay. Oh, so if you have like the half.
You have to double it
Okay.
to get the correct ratio. And now what's the coefficient of CO2?
17.
Nope.
16.
Very good. Plus. What's our last coefficient?
21.
Oh geez, we need to do times tables next.
Wait.
What's 9 times 2?
12. 18.
18, not 12, kids. Dear Lord, okay, but you know what? Maybe that explains some of the problems with the balancing equations. So again, you can break water into HOH, or you can use a fraction or decimal and then double the
Yeah, that's
equation.
hard.
Okay, thank you.